Hi students, in this video we are going to cover the position time, velocity time graphs of steady motion. The position time graph of a constantly moving object is as follows. The equal displacement in equal time intervals. You see that every 1 second there is a displacement of 10 meters. So when I put the values, then I have this graph. The slope of the position time graph gives us the velocity. When we take, let's say, it has an angle of alpha. When we take the slope is equal to the y-axis over x-axis. The y-axis have the value of displacement and the x-axis have the value of time. So the displacement over time will give me the velocity. And one more important thing, as you said, see that the angle doesn't change, so the slope is constant because the velocity is constant. Now let's find the velocity of this motion. Let's take this value. It displaces 40 meters in 4 seconds. So 40 meters to 4 seconds will give me the velocity of 10 meters per second. If the position time graph is as in the first one, you see that the position doesn't change. The slope is 0, so the velocity is also 0. So I have a velocity time graph at 0. In the second one, the position is getting in the right direction, in the positive direction. So slope is positive, so velocity is constant and positive. So I have a velocity time graph like this. In the third one, the object is going back. The slope is negative. The velocity is again constant but negative. So I have the velocity time graph like this. B. Let's compare the slope of objects A and B. As the slope of A is bigger than the B, and the slope gives me the velocity, so the velocity of A is bigger than the velocity of B. Can you match the graphs with given suitable situations? The first one, a motorbike travels away from home at a steady speed. It's always going in one direction. V is constant, and so I have the distance time graph in which the velocity is constant and there is no change of direction. The second one, a car remains parked in the car park. So you see that there is no displacement. The car is parked, so velocity is 0. So it belongs to the first graph. A runner runs at a steady pace to the end of a track, turns around and runs at the same speed back. It goes in one direction and then return back. So you see that going in a positive direction and then turn back to the starting point. Let's do an example by creating a velocity time graph from position time graph. In here you see that it's going in positive direction. Let's say this is 60 meters. So with a constant velocity between 0 to 10 seconds, the velocity is equal to, from the slope, 60 over 10, which is equal to 6 meters per second. So it will be velocity time graph like this. Between time intervals 10 to 20 seconds, let's find the slope. You see here that it is going back, so the slope is negative, so the velocity is negative. The displacement is minus 60 meters in 10 seconds, so velocity is minus 6 meters per second. So the graph will be in a minus 6, a negative graph. Another example, the initial position of the motion is 60 meters and the final position is minus 60 meters. So the slope is negative, which gives me the velocity as minus, you see that there's a displacement of 120 meters in 20 seconds. So minus 6 meters per second. The slope is the same at every point. So from 0 to 20, the velocity is constant, equal to minus 6 meters per second. We have another example. Now we are going to draw the velocity time graph from the given position time graph. We have 4 intervals between 0 to 4. There's a displacement equal to 1, 2, 3, 4, 5 meters. So between 0 to 4 seconds, the velocity will be equal to from 5 to 4 meters per second. Between 4 and 8 seconds, you see that there is no displacement. Its position doesn't change, so the velocity is 0. Between 8 to 12 seconds, it's going in the opposite direction. It goes from plus 5 to minus 5, sorry, minus 4. So the displacement will be equal to minus 9 in 4 seconds. So velocity will be equal to minus 9 over 4 meters per second. And after 12 seconds, let's till 16, 12 to 16 seconds. Again, there is no displacement, so the velocity is 0. Now let's draw this graph. Between 0 to 4 seconds, the velocity is positive, equal to 5 over 4 meters per second. Between 4 to 8, the velocity is 0. Between 8 to 12, the velocity is equal to minus 9 over 4 meters per second. And after 12 seconds, its velocity is again 0. The velocity time graph of a constantly moving object is as follows. There is no change in velocity, so the graph will be a line like this. The area under this graph gives us the displacement. So when I shade this area, the area under the velocity time graph gives us the displacement. This area is equal to displacement. Now let's find the displacement of an object whose velocity time graph is as follows. From 0 to 3 seconds, the area under the graph will be here. So the area is equal to 10 times 3, which is equal to 30 meters. Between the time intervals 3 to 5 seconds, the area under the x-axis graph will be here. So this area will be equal to minus 10 times 2, which is equal to minus 20 meters. Be careful that the area gives us displacement. Displacement is a vector quantity, so it can be negative. So the total displacement will be equal to 30 plus minus 20, which is equal to 10 meters. Creating a position time graph from the velocity time graph, we have said that the area under the graph gives us the displacement. So this area, the displacement is equal to 60 times 8, which is equal to 480 meters. So the position time graph will be like this. It is equal to 8. The position of the object will be equal to at 480. Here, be careful about that. The displacement is equal to the final position minus the initial position, and in this example I take the initial position as 0. Now we have a negative velocity, minus 60 meters per second. So the area under it, the displacement will be equal to minus 60 times 8, which is equal to minus 480 meters. So if the initial position is 0, there will be a displacement in the negative direction equal to minus 180 meters. Now we are going to solve another example. I have a velocity time graph. Between 0 to 4 seconds, the area under the graph is here, which is equal to 2 times 4, 8 meters. So I have, let's say here, 8 meters in 4 seconds, and draw this position time graph. Between 4 and 8 seconds, this shaded area will be the displacement, which is equal to from 5 times 40, 20 meters. So I have a displacement of 20 meters, so come to the position 28. It is equal to 8 seconds, and draw my position time graph. Between 8 and 12 seconds, there is no displacement because there is no area, so it will stay still for 4 seconds at position 28. Between 12 and 17 seconds, the velocity is negative, so he's going in negative direction with a displacement of equal to minus 4 times 5 minus 20 meters. So from position 28 go to minus 20 meters, so come to the position 8 in 5 seconds. The last example was total distance covered between 0 to 16 seconds. As the distance covered is asked, I'm going to find the area under the graph. So between 0 to 1, the area is this shaded part, which is equal to 8 times 2 over 2, 8 meters. Between 2 to 10 seconds, this shaded area is the displacement, which is equal to 8 times 10, 80 meters. Between 10 to 12 seconds, this shaded area will be the displacement, which is equal to 8 plus 4 over 2 times 2, 12 meters. And the last part, between 12 and 16, this shaded area, which is equal to 4 times 4, 16 meters, is the displacement taken. So the total displacement, or the distance, because he's going always in the same direction, is equal to 8 plus 80 plus 12 plus 16, which is equal to, let's sum them, 6 and then 16 meters.